Understanding physics in our everyday life. Physics is a branch of science that focuses on matter and energy. It is all around us. It can be found in almost anything we do. Some of the common things it involves is gravitational forces, energy, motion, acceleration, velocity, and other electrical currents, typically found in generators and or batteries. What is gravity? Gravity is all around us. It is not something that an average person thinks about every day, but it still occurs. So what actually is gravity? Gravity is a natural attraction between physical bodies, especially when one of the bodies is a celestial body, such as the Earth. Everything we do involves gravity, even something as simple as waking up in the morning. When we awake in the morning, the gravitational forces pull us down as we get out of bed. It is the reason we are not floating off the floor. Also, bouncing a ball uses gravitational forces because the gravity is what makes the ball fall to the ground when dropping it. Newton's law of universal gravitation states that every massive particle in the universe attracts every other massive particle with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This is stating that every massive particle contains a gravitational force. The equation to calculate how much gravitational force an object has is F equals G times M divided by R squared. The F in the equation stands for force. The big G stands for the gravitational constant, which is 6.7 times 10 to the 11th power. The large M stands for the mass of one of the objects you are measuring. The small m stands for the mass of second objects you are measuring. Lastly, the R in the equation stands for the distance between the objects that you are comparing. What is energy? Energy is something that is commonly heard of. It is in all things that can be described in multiple ways. The two most common types of energy are potential and kinetic. Potential energy is the energy that a piece of anther has become its position over matter, or because of arrangements of parts. As an example of this would be a ball at the top of a hill. The ball is using potential energy because the potential energy is energy at rest. Kinetic energy is a little different. Kinetic energy uses energy associated with motion. Therefore, it is energy in motion. An example of this would be a ball rolling down a hill. Since the ball is in motion, it is using kinetic energy. Motion is an act, process, or instance of changing places. Motion is typically associated with movement. In physics and everyday life, nearly almost everything stays in motion. Isaac Newton, who was a well-known physicist, came up with 3 laws of motion. The first law is an object in motion tends to stay in motion with the same direction and speed, or an object at rest tends to stay at rest. If a ball is rolling down a hill, it will be harder for it to stop, however, if the ball is at the top of the hill and nothing touches it, the ball will continue to stay at the top of the hill. The second law of motion states how the force acting on an object is equal to the mass of the object, equal to the mass of that object times its acceleration. This explains that a constant force acts on a massive particle, it can cause the object to accelerate. This can change the velocity at a constant rate. The third law of Newton's laws of motion states that every action there is an equal opposite reaction. Two common terms in physics. Acceleration and velocity are the two common terms in physics. These terms help describe the direction of an object. Acceleration is the act or processes of moving faster or happening more quickly. A common term to use for acceleration is usually speed. Velocity is similar to acceleration. Velocity is the rate of change of position along a straight line with respect of time. A perfect example to explain velocity and acceleration would be a vehicle driving down a freeway. When driving a car, the acceleration determines how fast the car is moving. Therefore, if you're driving 60 miles per hour, then the acceleration of the car would be 60 miles per hour. The velocity of the car changes. The velocity of a car, however, can change depending on the force of the car. The faster the car goes, the velocity increases. Momentum plays a part in the acceleration and velocity as well. Momentum is a property of a moving body that the body has by virtue of its mass and motion, and that is equal to the product of the body's mass and velocity. Another term that typically goes along with momentum is force. Force is the strength or energy exerted or brought to bear. When a vehicle is driving down the freeway, the faster a vehicle drives, the more momentum it has. The more momentum an object has makes it harder to stop. This makes the force have to be stronger and push against the momentum in order to make the object either slow down or come to a complete stop. When a car crashes, there must be a strong force exerted to get the car to stop. To calculate how much force a person feels in a car crash can be calculated. It can be calculated by how much the person weighs and how many miles per hour the vehicle was going at the time of the impact. For example, a person driving 50 miles per hour and weighs 150 pounds, the amount of force in pounds would be 7,500 pounds of force. This is because the momentum and force collide. Another example of momentum and force colliding would be throwing a baseball. When a pitcher throws a baseball towards home plate, the ball gains momentum. When the ball hits the bat, the momentum of the bat and the momentum of the ball collide. The force of the bat is what makes the ball go into the field. Electric currents is something that an average person does not think of when hearing the word physics. So since we cannot see electrical currents, it is harder to think of when thinking of what we use in physics. The electric system is an electric charge in motion. So how do electric currents work? Electrical currents typically work in batteries and generators the most. This is because when using batteries, the different ends have different charges. one side of the battery is a proton and on the other side is an electron. The proton side has a positive charge and the other side has a negative charge. Typically, the protons are immobilized inside the atom's nucleus. So it is usually the electron's job to get the charge from one place to another. As you can see, you can find physics in almost everything and everywhere you look. Physics are an important part of our lives, and we do not usually realize it. It can be in anything from gravitational forces, energy and motion, acceleration and velocity, momentum and force, and also in electric currents. These are not all the things physics are in. There are numerous other things you can find physics in, such as examples. Some other examples of things you can find physics in are cell phones, headsets, irons, and more.